So, is that okay? Does that work? Can you hear me? Yeah. I also have a weird interest in application bundling systems. I have written the three first ones are like experimental bundling systems I've done. Then Updatinator was like a peer-to-peer updating system for OLPC. And recently I've been doing a lot of work on Docker and Project Atomic. We're using OSTree, and I also sort of been involved in Leonard's Linux app proposal thing a while ago. So I'm here to talk about applications. So the core question is then, what's an application? And to be clear, I'm talking about desktop application, client desktop applications, like not web apps, not server-side apps, desktop apps. So what is an application? It's a piece of software that you use to get something done. A very generic definition, and it basically applies to all software. So I think it's more interesting to have the opposite question. What's an operating system? Because an operating system is not an app. There's, of course, the very computer sciencey definition of an operating system is like the minimal runtime that abstracts your hardware or whatever. But I like to have a broader view of what an operating system is, especially in the sense of a desktop operating system. So to me, an operating system, it includes the kernel and the core runtime, but it also includes the windowing system, the network management, configuration, the desktop shell, the toolkit, the icons, dbus, basically all the way up to the graphical shell that lets you launch something. And the exact line where you draw between what's an operating system and what's the app is not as important as the question of, or the fact that there is a line. At some point, the operating system stops and the app begins. And then comes the tricky question. Is a distribution like Fedora or Debian or whatever, is that an operating system? I would say they're not. It contains an operating system, but they also contain apps. And I would think anyone would agree that a bunch of the stuff that a distribution ships are really apps. And there's a problem here in that the way you design an operating system, you have a very special mindset. You're trying to create this minimal thing where you avoid duplication, you make sure everything works with the exact version that you bundle, and you test this whole thing, the operating system. But if you're in the business of developing and distributing an app, you don't really have the same core requirements. Your requirements are more like your app should have one build and it should work in as many places as possible. It should be possible to run on any distribution and ideally be maximally tested in a way that's isolated from the various desktops, the various distributions. You should be able to run the latest version of your app on an older distro. You should be able to keep running the older version as you rev your distro. And there should be a robustness against changes in the distro. Like if you upgrade your distro, you shouldn't randomly break existing apps. So the mindset you have and the two are kind of different. It's, in my opinion, very problematic that the distribution model tries to force the operating system development mindset on apps because they don't match. And I think this is fundamentally a very large scaling problem for the free software community, because there's no way for the distribution model to scale to something like the level that the Apple or the Android App Store does. For instance, we have a lot of useful apps, and I have nothing against distributions as such. I've been using one for 20 years. I've been developing one for 15 years. But take something as simple as I live in Stockholm, we have a subway system. The subway company produces this app you can download on iOS and Apple, on Android or iOS, and get, like, quickly search for the timetables and whatnot. This is true for any major city in the world. Could you ever imagine every distribution supplying these apps for every city in the world and keeping them updated and having them all in Fedora and then revving some base library and testing all of them? It just does not scale. It has to be a way for the developer of a particular app to do their own release and not having to rely on every distribution to pick it up. And that doesn't, to me, diminish the importance of the distro, because the distro is what does all the hard work in booting and running and getting a shell and configuration and integration. But yet we want the split and we want to allow third-party applications. So bundling is a dirty word in distro circles. It is, however, the one thing that is a tool we can use to create this kind of robustness. It has a bunch of drawbacks. Like there's a lot of duplication, both in terms of memory use, disk space use, but also like duplication of packaging. There's just work to package stuff. And also, bundling as such is not enough, because we cannot imagine a developer like the subway company bundling everything. I mean, we don't want to be in the position where they bundle a glibc or OpenSSL or some of these really core and complex things that you basically have to be a distro engineer to be able to do. So bundling as such cannot be the complete solution, but it is a tool that we have. And I believe, even though there are problems with bundling, such as security, errata, that it is an important tool. And we need to use it while minimizing the problems that it causes. So one of the main ideas I have, and we have, if anyone read the Leonard's post on runtimes and how he wanted to do distributions, it is very similar. It's very much based on those ideas. And one of the ideas is that we introduced a runtime. So you have, like, instead of having just the OS and the app, you have the host OS, which is typically some kind of distribution. And in between, you have something called a runtime. So every app specifies a particular runtime that they depend on. And the runtime itself is isolated from the host OS. And in fact, you can install multiple runtimes on a single operating system. Typically, you will have multiple versions of the same runtime because you're running old versions of old app that relies on the old runtime. And you could also even have multiple runtimes from different sources. And then, from the point of view of the app, the runtime is the operating system. It is /user that's the runtime. So all the libraries and stuff that's in /user, they come from the runtime, and they are isolated from the same library. Probably also exists on the host OS, but it could be a different build. It could be using like lib64 or lib. It could be a different zone name, but we're isolated from that. And instead, we have a much tighter integration between, a much smaller point of integration between the runtime and the host OS, which is basically a kind of IPC interface instead. We do have to support, like, the X protocol has to be stable so that the client libraries that we bundle in the runtime always work with the X server and the host. And then we also have the idea of sandboxing. I personally think sandboxing is very important, but it's also not everything. I think it's even just bundling is very interesting because it lets you run current apps unmodified on, say, multiple distros, and you can use testing development version on the current version of your distro and things like that. But in the long term, sandboxing is where it's at. Because first of all, it's a great way to mitigate the problems that bundling have. If you have some kind of exploit in the bundled image library or something, the idea is then if someone managed to exploit that, they will be in a position of having access to very little data. And in particular, we want to protect the user's data. I mean, and this is an area where Linux and Unix in general does really poorly right now. The Linux security model is all based on protecting root from me, basically. Protect the machine. And that makes no sense. I own my laptop. I don't want to protect it from me. I want it to protect me. And the most valuable information I have is in my home directory. I have my social security number, my Visa card numbers, my emails, my private data. These are the important thing that I want to be protected. And I think sandboxing is the only way we could have a shot at protecting us against apps. So it also allows a model where you have less trust in the distributor of your app. Like right now, if I add a remote Yum repository somewhere, I am handing them root access to my laptop. I mean, I'll be automatically downloading RPMs that spawn shell script that run as root and can do whatever. But if you have a sandbox model, you can have a situation where you can give less trust to a repository and even then install apps from there. Also in general, I mean, the security errata update model is less problematic in the scheme where we have runtimes and apps separately, because we can put the most problematic libraries and the most widely used libraries in the runtime, and then we can rev those separately and have share the development and maintenance work on those. So if you have an old app, so it will still get your new OpenSSL as part of an update to the runtime. So the first thing I want to introduce today is my project called XDG app. Not the greatest name, but in fact, I think kind of having a boring name is useful because it's supposed to be used as base thing. It's a simple tool that uses OSTree. I don't think does everyone know it? Does anyone not know what OSTree is? Okay, so it's kind of a Git-like storage for for file system trees, typically operating system trees. So you can have a repository and then commit a full file system tree, and then you can update that, and you can roll back, and every commit gets a SHA-256 ID, very similar to how Git works. And in fact, the whole backend is also Git-like in that every file in your file system gets stored in a content addressed way as a SHA-256 hash, which is very nice. You get automatic deduplication when you download, and if you store multiple trees and only a few files changed, you don't store things many times. So it uses that as a way to download initial versions and updates. And it uses also to have multiple versions installed and to do we do a clone, and then we do a local checkout that is hard linked to the repository. And then there's kind of a minimal runtime that spawns an application that you have installed, picks up the right version of the runtime that it's supposed to use, and then starts it in a sandbox. I also have done something called the Gnome SDK, or I don't know what the best final name would be, but it's basically a runtime that packages the core Gnome platform in a minimal runtime that has the core things that an app needs, but it doesn't have anything that a real operating system needs. There's no server-side part of things. There's only, so it has the client X libraries, it has glibc, image libraries, crypto libraries, it has Mesa in there, Wayland, dbus, glib, GTK, some icon stuff, but it doesn't have the X server, it doesn't have UDEV or anything hardware related. In fact, there's actually two runtimes. One is the platform, which is what apps would use. And with the platform, there's a corresponding develop version called the SDK, which has everything that's in a platform, plus the headers, the soap files, it has GCC make, it has all the tools you need for building and debugging. It's got Valgrind, GDB, everything you need to build stuff for that platform. In fact, there's also two more runtimes I added recently, like they call the free desktop ones. And it's basically just the GNOME ones without the GNOME stuff. So it's only X, Mesa, Wayland. I think glib is in there, but it's really maybe more targeted towards packaging games or minimal things. So I was hoping to do better than Alberto here, but you see that? Yeah. So XDG app is the tool you use, and it's also the command line interface is very similar to something called like Git or OSTree, where you do the command name and then like subnames, and then what we do here is create a opt repo is a local repository. It would normally be a HTTP thing or something, but for the demo purposes, it's a local thing. So I create a repository called local, and it's --user means I'm installing this as a user. You can install both as user into your home directory or as system, but then I have to be root. So I do that, and then I can do xdg app like install runtime from the local or not. Whoa. Yeah. Hmm? What is that? What? Demo gods work. Oh, it's there. Oh yeah, that's it. That was a bad error message. Yeah, you had to specify the branch. I guess it was assuming master. Oh. So we have the repository install, and then I have I can do xdg. I made a bundle of Builder, which is like, if anyone has not seen it, it's the cool new IDE thing that Christian Herget is doing for GNOME 3.16. It requires GNOME 3.16, and this is a Fedora 21, so I couldn't normally run it here. So I don't have it here. But if I just do this, it should install. Bam. It's running in its own sandbox that has the runtime as /user, but it still integrates with the desktop. It uses X or Wayland or whatever to do rendering. It uses Pulse Audio for audio, and right now it uses dbus, but long term we want to use KDbus. Can actually very similar to. You can also run it manually. Like that, or you can run. You get a shell inside a thing, and you see such user here is the runtime. /self has the bundled app. It's 12 megs. So it's kind of a minimal. There's still a bunch of stuff in here, but it's kind of smallish. What else can I show? Install the SDK. It's a bit larger. This takes a while. And then I can actually run this against the Devel runtime instead. Then I have things like GDB and Valgrind. See, things like that. So that way, if I have something, I can just automatically get the corresponding debug thing and start debugging it. So how does it work then? An application, when it's installed, is actually just a tree of files that we manage in OSTree. So there's a file called metadata that has information about the file. About the app. It's like name, what runtime is it using, what SDK was it done, what kind of requirement does it have, how do I start the app. Then files are just the files that are in the app. And there's a separate directory of files called export, where you put anything that needs to be exported to the base system when you do an install. It typically has things like dbus, service files, desktop files, icons, things that need to interact with, like GNOME Shell or file manager. And the metadata file looks like this. It's a key file. Has the runtime, the SDK. Well, the SDK thing is optional, but it's nice to have it. Specify what you're allowed to access, and obviously this thing can do whatever. But if you disable a bunch of these, it'd be more or less a sandbox. Although we're not yet fully sandboxed. That's the plan. But I mean, if you leave these out, the host FS and the home directory, then at least you can't see your files. Although I mean, you can still use X to like snoop on all keyboard and input, steal your password on unlock and shit like that. So the runtime is very similar to an app. It doesn't have exports, and the metadata is slightly different, but it's basically the same thing. And when you run something, we create a new tempfs, which is the root of your it has a new file system namespace that it runs in. And the tempfs has a /user, which is a read-only bind mount into the runtime files. They're all like no dev, no setuid, so it's kind of safe. They're read-only, so you cannot modify anything. /self has the bind mount to the files from the application. Similar there. var is a bind mount to a per user, per app directory. So any app has some place where they can write stuff. Like if you're writing an app that is a game and it wants to stream cached data, some 3D world or something, you can store it. You can always write to /var, and it will actually, it's mapped. If you do a system install, there's a per user version of this, and if you have multiple apps installed, the var is shared between all versions of a particular app. So if you do an update, you keep your old data. Home user or whatever, where your home directory is say bind mount or symlink or something into var home. So anything that you package that writes to your home directory, .file or something, will just work, unless you actually give the app full access to your home directory, and then it will be your normal home directory. Etc bin on lib are symlinks into user, because we don't have anything outside user. Temp is just on the temp fs, and then we have a minimal proc dev sys. Proc shows you only your own processes because we're using PID namespaces. Dev is not actually dev, it's like a minimal, it has dev null, dev full, dev zero, and all that kind of stuff. Also, it does have some things. Dev DRI, for instance, has to be there for 3D to work, but those are mostly safe. It doesn't have any direct hardware access as such.
What are the namespaces you use?
Right now, it just uses PID and file system, but you can also use network namespaces. If you specify network equals 0 or false, then it only gets its own file its own network namespace with just the loopback and nothing else. But if you do give it a network, it uses the host network namespace. There's also a separate flag for IPC. If you don't do anything, you get your own IPC namespace, but you can specify IPC equals yes, and you have to do because shared memory doesn't work without the host IPC namespace. But Wayland, that will be fixed. Yeah, those are.
Did you have to change builder or GA to make this work?
No. Well, I mean, I rebuilt it, but I didn't have to change any source code. Just it worked well. When you actually install something, it gets installed into a directory. There's var xdg app is for system installed things, and you have a producer local share xdg app. In there, repo directory is an actual OSTree repository, and in that repository, everything you have installed, be they runtimes or apps, they are branches. Every installed thing is a branch, and the branch name looks like the first directory, that runtime /org.gnome platform. All that is the name of the branch, and then we have a checkout out of it, checkout from the repository into that those subdirectories, and that large number there, it's like the Git ID. It's the SHA-256 of the tree we're checking out, and that's actually hard linked into the repository. So there's no duplication going on here. It's actually the same. In fact, if you have multiple versions of something checked in and they share files, they will all share the same file in the OSTree repository. And then we have the actual checkout we have. It's a subdirectory, which is the SHA-256 hash. So if you do an update, you do a separate checkout right next to it, and then we delete the old one only when it's not running anymore. So it's actually completely safe to do online updates. All we do is we clone the new version right next to it, and then we remove the old directory, and then we wait with deleting the old one until it's not in use anymore, and we use some bizarre file locking tricks to detect if it's running or not. There's also a checkout of an app here, and it has a data directory, which is where we store the /var data for the app. There's also a top-level export thing where at install time, we explode the exports from each individual app into this global thing. We do some rewrites to update the desktop files so that they actually work. We rewrite desktop files, we rewrite debug service files. We run triggers to regenerate icon caches, to regenerate like the desktop files and desktop file databases, things like that. And then what you do is you just make sure, like, tilde local share xdgapp/export/share is in your xdg datadirst environment variables, and then the shell just picks everything up and it works. Well, it's actually kind of painful because you have to make sure that dbus gets the environment's variable set, which is needs to happen very early in login, but if Fedora were to do it, it would just work. There are some new complexities here that we did not really have to care about before. There's some kind of prerequisites from on the host OS from a runtime, like if we bundle the DRI drivers, the client-side DRI drivers, the host OS better have the right version of the kernel DRM drivers. And if you're using some new syscalls, they better be in the kernel. There's also the fact that we're using services that use IPC to talk from the client to the host. The obvious ones are Wayland, X, Pulse Audio, but it's also the fact that we're probably relying on dbus services running in the session. So if you have dconf daemon running in the session and the clients talk to it, we bundle the client library and the app that uses it with the runtime and the app. And if you rev the OS, it better support the exact protocol and the exact same dbus APIs. So this forces us to be much more careful in forwards compatibility for dbus interfaces. Like we cannot, I have personally, like doing things like maintaining GVFS just changed the dbus interfaces because you always update the GVFS daemon and the client libraries in the same update. I mean, they're just part of the same source build. Why would you have a mishmash thing? It just, and if you did, it was probably a major update and you reinstalled your operating system or upgraded it, and then you did a logout anyway. So, but in this case, we have to always support running older client libraries with newer version of your services. So this becomes much more important. And in general, this is ABI compatibility is not as important anymore because we're free to break ABI when we release a new runtime version, but IPC can never break. Ever. That's a long time, of course, so we probably eventually break old stuff, but it's got to have a lot longer lifespan than regular ABI. We also have some tooling to build apps. It's not really any tooling to build runtimes because it's very low level and hackish. Actually, the Gnome SDK uses Yocto as the base. It uses the Yocto build environment to set up the base thing, and then we build custom RPMs for the higher level stuff. But if you want to build an app, we have a couple of commands to XDG app. There's build init that basically generates a file system structure that has reference to a particular SDK and runtime. And then you can just run the build command, which runs in that directory as if it was an app, except it's writable. So you can just do configure, make, install, and that will use the build tools from the SDK, and then install itself, which ends up being in your app. And then at the end, you just run build finish to set some details and specify how you start the app. And it would also export anything from your, if you install the desktop file, it will auto-detect this and put it in the exports directory. And then build export basically commits to a OSTree repository that you can then mirror or rsync or whatever to your server. And then anyone can download it. this is particular to the Gnome SDK, but we do ship a version of RPM and RPM build that is configured to always set prefix to /self. So if you have existing spec files, they should more or less work with just a -- rebuild on the RPM. Maybe you have to do minor changes to the dependency names, but it more or less should work. And I think we want to have like a repository of SRPMs that you can easily use for bundling, because some things actually do require some tweaking to work in the bundling environment. Most things don't, but some do. So it's nice if we can share that work between apps. Right now, the sandboxing aspect is not very, it's not really implemented, and we are going to have to do a lot of work on the core desktop and OS to make it possible to have sandboxing that works. First of all, X has to go. Wayland is the only thing that could ever be secure in this. And also the same is true for Pulse Audio. We have to not maybe replace Pulse Audio, but at least fix it so it doesn't give you full access to any audio source or any microphone, as long as you can connect to the Pulse Audio daemon. We need KDBus for kernel level filtering of dbus APIs. I mean, that's not necessarily super requirement. We could just say that the app can't use dbus, but then it's not very useful. If we want to expose dbus, we need kernel level filtering on what we can access and not. And that requires KDBus. We want to use SLLinux to do a better, tighter sandbox, C groups for the same thing, device C groups and just C groups in general to make sure that no process escapes your container. More use of namespaces. But this is all like to tie down the app very heavily. But to actually work, an application needs to integrate with its environment. So we have to start punching holes in the sandbox that we deem are safe. Like, for instance, you couldn't have an app in a sandbox use the regular GTK file selector, because it reads your files from your home directory, it returns a path name and expects the app to just read that. Instead, we have to add new APIs. We're calling them portals, which are secure ways to access stuff outside your sandbox. So you'd ask the portal servers for file selector, give me a file, and then we'll do the file selector outside the sandbox, and then at the end, just return the data from the file that was selected. And then we have to have new APIs. I'm not even sure how they would look, because if the app then edits that file and wants to save in the same place, we have to have some kind of API so that you can have an opaque reference to what you loaded and be able to replace it with new data. And there's going to be a bunch of APIs like this that we have to add to the desktop, basically, to support sandboxing of the desktop application. That's actually going to be a lot of work. There's also more details, like how do we do webcams in this, how do we do printing, how do we do scanners, things like that. Yeah.
Is it possible to have two different versions and have them installed at the same time?
Oh yeah, it
So,
is.
you know, like I have the beta version.
Yeah, it is. It's certainly, it's clearly possible. So there's some issues with having the exact same thing installed, because the desktop file names will be the same, and they will shadow each other in some way. And unfortunately, the desktop file name is tied to the dbus name, which has to be unique. So if you had a separate build of GIMP devel that has a different name, that would work fine. But for a particular version, or for a particular exactly the same build, you can have two installed, but only one of them can be the active one that you can see that gets integrated, that gets started via dbus or the shell, or things like that. Right, out of time. Here's some references if you want. And I guess Do we have time for questions? No. All right. Not that then. A quick one.
Quick one, yeah. I don't know how quick. So if, let's say Fedora or Debian or Gentoo or so, they want to support this now, how much work do they have to do? Just XTG app?
Yeah, if someone ships XTG app, they should be able to run things.
Yeah.
And we as Gnome are going to be shipping a binary build of our SDK and our platform. We will also have something that you can rebuild, because I would believe it's in the interest of Fedora to ship this by default, a version of it, so everyone doesn't have to download it. So they would probably have a build of it. Fedora could also, if they wish, do their own runtime, their own SDK. I don't think you want to have a huge proliferation of millions of runtimes, but who knows what will happen. Sorry. If anyone has questions, ask me in person. I'm around.